In this video, we are going to be taking a look at different trends that we're able to find on the periodic table. The first trend that we're going to take a look at is going to be the shielding effect. Now, the shielding effect is going to be the inner electrons interference, or they are going to shield the valence electrons from the nucleus. So, the nucleus is trying to attract the valence electrons. Keep in mind that the nucleus is positively charged and the electrons are negatively charged. So we have a positive and a negative, and they're wanting to come together. Now, those inner electrons are going to shield the nucleus from those valence electrons. So the more inner electrons we have in an atom, the more that they are going to shield the valence electrons from the nucleus. Now, if we take a look on the periodic table, our trend for shielding effect is going to increase going down a group. So as we move down a group, what is happening is that we are gaining more and more inner electrons. So keep in mind that as we move down this group, all right, what we're also doing is that we are increasing the number of energy levels that we have for it. So the more energy levels we have, the more inner electrons we're able to have as well. So we're going to increase the energy level as we go down. The next that we're going to take a look at is going to be nuclear charge, which is going to be the effective charge of the nucleus, or essentially how much force the nucleus has on those valence electrons. Now, the nuclear charge increases as the number of protons increases within a row. So if we take a look at the periodic table, our trend for our nuclear charge is going to increase going from left to right. So as we go from left to right in each row, what we are doing is that we are increasing the number of protons inside of the nucleus. The more protons we have inside the nucleus, the stronger the force the nucleus is able to put on those valence electrons. Now, the nuclear charge and the shielding effect are going to be our reasons why all of our other trends happen. So as we go through these other trends, we are going to refer back to the nuclear and shielding effect in order to explain why those trends happen. Now, the first trend that we are going to talk about is going to be our atomic radii. So this is going to be the atomic size, or the size of the atom. And we're going to measure that by the distance from the nucleus to the valence electrons. Now, why this trend happens? So looking at our shielding effect first. As more inner electrons are added, the more shielding the valence electrons have, causing a decrease in attraction. So the more inner electrons we have, the less attraction the nucleus has to the valence electrons, and so they are going to expand outward. So we're going to get a larger atom the more inner electrons we have. Then we have the nuclear charge, which is going to be as the nucleus gains more positive charges, that force of attraction on the valence electron is going to increase, causing the atom to become smaller. So as we increase the protons in the nucleus, they're going to have a tighter attraction to those electrons, and they're going to pull those electrons a little bit closer to the nucleus, causing the atom to be smaller. Now, the trend that we have for our atomic radii, or atomic size, is that it is going to increase size going right to left, and it is going to increase downward. So what this means is that francium is going to be the largest element on the periodic table. So again, our francium is going to be the largest element on the periodic table. which means on the other end of that, our helium is going to be the smallest atom that we have on the periodic table. Let's go ahead and take a look at a few practice examples. So whenever we have a periodic table, I do suggest to go ahead and look at the trend. So our trend is going to increase from right to left and increase downward. So we'll just go ahead and draw that real quick. All right, so in our first example, we're going to circle the larger atomic radius. So we're going to compare lithium and francium. Now, as going through this, I would suggest just kind of highlighting, just making note of where these are. So we are going to have our lithium versus francium, or sorry, our fluorine. So our fluorine will be over here. Sorry. So our fluorine and our lithium. So if we take a look and everything at the trend, we are increasing right to left, meaning that the lithium is going to have a larger atomic radius because it's going to follow that trend. So that will be our lithium. Let's go ahead, we'll reset. Taking a look at our Sn and our Sr. So we'll find these on the periodic table. We have our tin, our Sn, and then we have our strontium being our Sr. Following the trend, we're increasing right to left. We should notice that the strontium is going to be larger. So our strontium will be the largest of these two. Taking a look at our third one, we have our sodium and rubidium. So we have our sodium and we have our rubidium. Following the trend, we are going to increase in size as we go down the group. So we should be able to recognize that rubidium is going to be the larger atomic atom size that we have. Now, another way that we are able to ask these types of questions is to arrange them in order of increasing size. So we have our TC, Y, and CD. So we'll go ahead and we're going to highlight those real quick. So we have our Y, we have our TC, and we have the CD. Taking a look at these, following the trend, we are just in a single row. So we're going to increase right to left. So how we're going to have this, so increasing order. So we're going to start with the smallest. So our smallest that we're going to have is going to be our CD. Then our next largest will be our TC. And then the largest that we are going to have will be our Y. So increasing size means that we're going to go from smallest to largest. Let's go ahead and take a look at our next example. So we have BE, we have MG, and CA. Looking at the trend, increasing from smallest to largest, we should be able to recognize that our beryllium is going to be our smallest atom. So our BE, followed by our Mg, which will be in the middle, and then our calcium will be the largest that we have. Taking a look at our last example, we have our Te, we have our I, and we have our Xe. All right, so looking at the trend again, we're going to increase in a row going right to left. So that means that our smallest will be our Xe, the middle will be our I, and then the largest will be our Te. So going from smallest to largest. And that is going to be how we take a look at atomic size. Now, along with atomic size, we also have ionic radii or ionic size as well. So, this is going to be the distance from the nucleus to the valence electrons of an ion. So, we should remember that ions are atoms that have either gained or lost electrons. So, cations will lose electrons, and because they're losing electrons, they're going to be smaller than our normal atom. Anions are going to gain electrons, and because they are gaining electrons, they are going to be larger than what our normal atom is. So let's go ahead and take a look at a few examples of this. So our first one is going to be our Mg plus 2 and Mg plus 1. We're going to go ahead, we are going to circle whichever one is larger. So remember, a positive sign means that it has lost electrons. So what we need to ask ourselves is our magnesium plus 2, this has lost 2 electrons. Our Mg plus 1 has only lost 1 electron. So which one do we think is going to be larger, the one that lost 2 electrons or the one that only lost 1 electron? So because our Mg plus 1 only lost 1 electron, it is going to be larger than our Mg plus 2 because it only lost 1 electron, not 2 of them. So our Mg plus 1 is going to be the larger ionic size. Taking a look at example number 2. So we have our carbon -2, carbon plus 2. So remember, if it has a negative charge, that means that it has gained electrons. Positive means it has lost electrons. So from that logic, we should recognize that if we gain electrons, we are going to be larger than normal. So our carbon with a -2 charge is going to be larger than our carbon with a +2 charge. So the carbon -2 gained 2 electrons, so that is going to make it larger. Our third one is going to be our fluorine plus 1 and fluorine -1. Again, a positive means that we have lost electrons, a negative means we have gained. Our fluorine -1 has gained 1 electron, which will make it larger compared to our fluorine that has lost 1 electron. And taking a look at example number 4. So we have our oxygen with a -2 charge, nitrogen with a -2 charge, and carbon with a -2 charge. So because these are different elements, let's go ahead and take a look at where they are on the periodic table. So we have our oxygen, we have the nitrogen, and we have the carbon. Now, all of these have gained 2 electrons. So because they've all gained 2 electrons, we're able to assume that they have essentially grown by the same size. So they have all gained 2 electrons, they've all grown by the same size. So we can just take a look at what the normal ionic size trend is, which is going to increase to the left and increase downward. So from this trend, even though they are ions, we should know that the carbon with a -2 charge is still going to be larger because it's the largest on the normal periodic table trend, and it has also gained 2 electrons as well. So that is going to be how we take a look at our ionic radii.